Doctoral candidate Anna Ylinen is developing biopolymer production in yeast.
And I'm using synthetic biology methods to adjust the properties and making the production hopefully cheaper in the future. I'm producing especially PLA, which is polylactic acid, and then different copolymers with that, also polyhydroxyalkanoate, BHB. Usually the lactic acid itself is produced with microorganisms and then it's purified and polymerized with chemical methods. But now we are producing both the lactic acid and the polymer already in the same cells in vivo.
Anna's research is based on the activity of various engineered wild-type PHA synthase enzymes. PHAs, or polyhydroxyalkanoates, are natural polymers made by bacteria found both in soil and marine environments.
They are completely watertight, so it looks and feels like a normal plastic, but it's biodegradable and compostable.
Ylinen has transferred different bacterial and fungal genes to yeast in order to broaden the feedstock base.
I'm modifying the yeast cells that they would learn to use cellobiose as a raw material instead of glucose. So we would want to use sugars derived from, for example, from cellulosic biomass instead. I've produced polyhydroxybutyrate, BHB, with cellobiose, and I've compared two different enzymes inside the yeast cells. That one of them is using the cellobiose a bit more efficiently and faster, but the other one would have more beneficial features regarding how the cell divides the energy inside it. So we are kind of trying to find the optimal way to use the cellobiose for these purposes, but also for other applications.
Ultimately, this could even entail using industrial side streams as raw material.
The bacteria cells are efficient of what they do already at the moment, but yeast cells have a lot of potential for using industrial waste as a raw material, so for using new different carbon sources, since yeasts tolerate low pH and harmful compounds very well, so maybe we can take directly some industrial side stream and we don't need to pre-treat it that much in the future.